Okay guys, here's our next segment on our video series for Unit 8, the stoichiometry of chemistry. What we're going to talk about today is percent composition. Basically we're talking about how is the actual molecule or compound composed and what percentage is everything inside that compound. Okay. Now, if we know the components of our compounds, we can basically break those down by mass, finding their different percentages. If we don't know the compound, we can use lab data to determine what percentage we have by separating out the substance and then doing it that way. So there's two different ways we can solve for percent composition, and we'll cover both in this little video segment. If we take a look at these two graphs, you'll notice that we have two different compounds. We have potassium chromate and then potassium dichromate. When you're making something like potassium chromate, it's possible that if you run the experiment too hot, too cold, different pressure, wrong pH levels, you might make this instead of what you're trying to make, which would be the potassium chromate. Now what a chemist can do is they can take a sample of what they produce in lab and they can do a test on it to figure out what percentage of each substance they have. So if they end up with 40% potassium, 27% chromium, and 35% oxygen, they know that their compound is most likely potassium chromate. However, if they run the test and they're getting more like 27%, 35, and 38%, they know that they didn't make the potassium chromate, but instead they made the potassium dichromate. So they made the alternate version of these two similar compounds. Now this is done very commonly in organic chemistry, where you're trying to produce a certain organic compound, a certain carbon-based substance, and with organic chemistry you need to be very careful about temperatures, pressures, pH levels, alkalinity, those kind of things. And if you get it off by a little bit, you actually can make something completely different, which then would be not what you're expecting or what you want to use for that chemistry lab. So percent composition is a way for us to test or determine what our compound is really made of, and then we can match that back to known percentages of known compounds. So if we go to the math side of percent composition, how do we actually calculate this? It really is no different than calculating a grade off of a homework assignment or a test or a quiz. If I told you you got 18 out of 20 on a homework assignment, in your brains you're probably saying 18 divided by 20, that's 90%. Well, you just calculated a percent composition of correct answers. If I said what percent did you get wrong, you say, well, I got 2 out of 20 wrong, so 20% was wrong. Sorry, 10% was wrong, it should be. If we take a look at our equation, your mass percent is just the mass of the element in the compound divided by the mass of the compound. So as long as you know how much mass each element contributes and you know the total mass, you can solve for percent composition. So let's go down here and let's actually solve this one together on the board. So what is the percent of iron in iron 3 oxide? Okay, so iron 3 oxide, we first need to know its formula. So iron is Fe. We have oxide, it's iron 3 oxide, so it's a 3 plus and 2 minus. We have plus 3 and 2 minus, so I need to have 2 irons and 3 oxygens. Now, breaking this down, I need to know the total mass of the compound. So what I'm going to do is say, well, I have iron, I have 2 of them, I have oxygen, I have 3 of them, and we're going to put down our molar masses. So if we look up the atomic mass of iron, it's 55.84 something here, 55.845. So rounded to hundredths place, I'm going to say 55.85 grams per mole. Oxygen is 16.00 grams per mole. And then I'm just going to total it all up. So if we take 2 times the 55.85, I get about 111. Let's get the exact number. 55.85 times 2, I get 111.70 grams per mole. And then 16 times 3, we get 48 grams per mole. Find the total, and 111.7 plus 48, I get 159.70 grams per mole. So what I've done is I've actually just done a molar mass calculation, and I found the molar mass of iron 3 oxide. Now, to get its percent, well, iron contributes this amount, oxygen contributes this amount. So the percent of iron would be 111.70 grams per mole divided by the 159.70 grams per mole. Grams per mole is on both sides, so that cancels out. Take this divided by that, take the whole thing times 100 to get a percentage, and we should get to our answer. Okay? So if we do that, 111.7 divided by 159.7, I get 69.94 something 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 percent. Okay. Here I'm working with, looks like 5 sig figs, 5 sig figs. All of this data came from the periodic table, which is really nothing measured. So I'm just going to kind of match up my precision as is and give my percentage out to the hundreds place here also. If this was lab data, then we would use significant figures. But because this is not lab data, we really don't need to use significant figures for our answer. So I get 69.94% iron. Now, what's the oxygen? You could solve that two ways. You could take the 48 divided by 159.70, or you could just take 100 minus this and get to your final answer for oxygen if you needed that also. Okay? So let's go back up to the screen, and if we take a look, sure enough, there's my answer, 69.94% for my percent composition of iron in iron 3 oxide. Okay, when you're working with percent composition, there's two different ways of solving things. We just did an example basing off of a formula that was known, but we also might have lab data. So we had to be able to solve from both things. So let's kind of walk our way through that. When you're working, step one, determine the molar mass of the compound. Okay, we just did that as our example. However, if you're in lab, you want to know the total mass of your sample. So maybe that's the starting mass of a compound that you measured out on a balance or something like that. So you have your starting mass. Then you want to determine the mass of each element contributes to the molar mass. Okay, so basically you want to break it down by element. If you can't do that, you want to work through your samples again in the lab. So maybe you did an experiment where you have a total and you can separate it and you have two different pieces. Then you can find out your individual pieces. Finally, divide it out. Same deal for lab, and then multiply 100 to get your percentage. Okay, guys, we have two example problems here we'll do in class tomorrow. So please make sure you finish up the video, and the next two slides are example problems that we will start with in class. Thank you.